To enhance our ability to further integrate trig functions, there are a number of formulae that we need to be familiar with. Okay, and on our information sheet for the Maths Specialised course, you can see what we've got here. This year it's a little bit different. Basically, there's a number of them that the number has been reduced a bit on this because they're being doubled up on the methods sheet. Okay, but if we have a look at what we've got, our basic trig identity, the Pythagorean identity, sine squared a plus cos squared a equals 1, and derivations from that, which are over here on the right hand side. 1 plus tan squared a equals sec squared a, and 1 plus cot squared a equals cosec squared a. Okay, and we also have these products to sums and sums to products formulas. And if we then just go to the methods and we scroll through, we can see these multiple angle formulas. Okay, these double angle formulae, along with these ones here, sums to products. So you can see that there are different collections of formulas which are useful in terms of finding just expressions, means of expressing some trig outcomes. And they're useful when it comes to integrating and when we have trig functions. So what we're going to do from here is look at integrating trig functions, and we'll go through a series of processes involved, okay, given different circumstances. And the first of those are looking at powers of sin x or cos x. In other words, problems of the form sin a x, so that's sin x all to the power of a times cos b of x, or cos x to the power of b. So the a and b here are powers, and just looking at different options, different alternatives or situations given whatever these values of a and b are. So what we need to consider first is if a, okay, so that power of sine, if a is odd, what method do we use? We use substitution. Okay, so it's worthwhile noting these things down, and specifically we use the substitution u equals cos x. Secondly, if b is odd, okay, so the power of cos, if that's odd, use the substitution u equals sine of x. Okay, if both powers are odd, basically we use either. However, if we substitute for the higher power, the algebra will be easier. Okay, so let me just summarise that again. If the power of sine, okay, is odd, then substitute u equals cos x. If the power of cos is odd, then use the substitution u equals sine x. If both powers are odd, it doesn't matter, but substituting for the higher power, the algebra will be easier. If neither is odd, then we use a different method. And we'll get to that. Okay, we'll get to that. So let's look at a few examples. Okay, so we've got here our first example. Find the integral of sine to the power of 3 of x. And remember, if the power of sine is odd, then we use the substitution u equal cos x. And from that then du will equal negative sine x dx. Okay. Now the question is, when we look at this we think, well, there's no cos to substitute. But let's go on and let's see how it works. Okay, so what we can do here is we can say that this is the same as sine squared x times sine x dx. Okay, now if we have a look over here at our basic Pythagorean identity, alright, sine squared a plus cos squared a equals 1. If we rearrange this so that we have sine squared a as our subject, then sine squared a is equal to 1 minus cos squared a, and that's what we need to use here. Okay, so this then is the same as 1 minus cos squared x times sine x dx. So now hopefully we can start to see what's going to happen. We've got cos squared x here, so we're going to replace that with u squared. So in our integral we've got 1 minus u squared instead of 1 minus cos squared x. And see here now we've got sine x dx, and that's what we've got here, except it's negative sine x dx is equal to du. So what we need to do is we can put a negative out the front here and change this to du. And now what we can do is put negative out the front and integrate both of these terms. So this is u minus u cubed over 3 plus c, and now negative u plus u cubed over 3 plus c. And of course u represents cos x, so we can replace that. Negative cos x plus cos cubed x over 3 plus c is our final answer. Okay, what we probably ought to do is just to specify here what c represents. We know that it's representative of a real number, so we probably ought to write that down. Okay, it's a constant term clearly, but that specifically it's a real number. Okay, and so just just specifying that there when we are doing that. Okay. Alright, so let's have a look at another example. Okay, so this time we've got finding the integral of sine x to the power of 7 times cos x to the power of 3 dx, and this is a situation where they're both odd, and so it doesn't really matter which we substitute for, but we're going to do it for the higher power. Okay, so what we'll be doing is letting u equal sine x. Okay, and then du will be cos x dx. Okay, so where to from here? Well, because our du is to replace cos x dx, we don't want there to be essentially 3 cos x's here, okay, multiplying together. So we only want 1. So what we're going to do then is change this so that we've now got this will be cos squared x. Okay, so well, at this stage I don't really need that there, so I'm just going to write cos squared x times cos x dx, because this cos squared x going to replace with 1 minus sine squared x times cos x dx. Okay, so we need to sort of be able to look ahead with these types of problems and to see how we can go about substituting. It's being able to see down the track. It sort of doesn't jump out straight away. We need to be able to look at it and see what we can do. Okay, so when we do that, we can now substitute our sine x with u and replace cos x dx with du. Okay, so the sine 7 to the power of 7x, that's u to the power of 7 times 1 minus u squared du. Okay, and we can expand this now, so we'll end up with u to the power of 7 minus u to the power of 9 and now we can integrate those. So we'll have u to the power of 8 over 8 minus u to the power of 10 over 10 plus c, where c is a real number. And now we can replace our u's back into sine x. So that's sine to the power of 8 of x over 8 minus sine to the power of 10 x over 10 plus c. And that's our solution there. So we'll leave it at that, and we'll come back and do another video with more examples.